Southern men, the thunders mutter, northern flags and south winds flutter. To arms, to arms, to arms, to arms, in Dixie. Send them back your fierce defiance, stamp upon the cursed alliance. To arms, to arms, to arms, to arms, in Dixie. Advance the flag of Dixie. Hurrah, hurrah, for Dixie's land we take our stand and live or die for Dixie. To arms, to arms, and conquer peace for Dixie. To arms, and conquer peace for Dixie.
Major Jackson, what news is there from the battlefield?
General Lee, we were able to cut the Yankee regiment off from their supply lines. We've sent a couple garrisons to chase them deeper into the south. From there, General Kermes can flank them in the rear.
Very good. Soon enough, the North's aggression to stop the institution of slavery shall be at an end.
There was one other thing. Our men discovered battle plans on the captured Union soldiers.
Oh, what plans are these? Tell me more.
It seems Lincoln has been developing this idea called electrical engineering. If you ask me, it sounds like a bunch of hogwash. But the plans we found document something called the GENROU and the GENSAL model for a synchronous machine. You see, in the North's plans, they are going to create this thing called an electrical grid. An electrical grid is a network of power plants, transmission lines, and distribution centers that delivers electricity. The power plants will generate the electricity. The most common type of power plant will be utilizing a synchronous generator. In Lincoln's plans, power plants such as nuclear, coal, natural gas, diesel, and hydro, to name a few, will use synchronous generators to create electricity. The most insidious part of Lincoln's plan is that he'll need engineers to simulate power systems. So those damn Yankee softwares such as PSSE will have to model these synchronous generators. That's where the GENROU and GENSAL models come into play. They represent an average approximation of the electromechanical transients of a round rotor and a salient rotor synchronous generator. These models are very useful in the North's plans as they allow engineers to easily model systems. They are frequently used in transient stability analysis, fault studies, and grid impact assessments for large power plants. Now let's define the two major types of synchronous machine: round rotor and salient pole. A round rotor, or cylindrical rotor, synchronous generator is a type of generator where the rotor has a uniform, cylindrical shape without any physical poles visible on the rotor surface. The rotor is smooth and typically longer, which helps with mechanical stability at high speeds. The rotor windings are distributed along the cylindrical surface, creating a magnetic field with poles only through electrical excitation. Round rotor generators are designed for high-speed operation, typically 1500 to 3600 RPM. These generators are commonly used in thermal and nuclear power plants because they can operate at high speeds, which aligns well with the high-speed turbines in these facilities. A salient pole synchronous generator has a rotor with physically distinct poles that stick out or salient from the rotor's surface. The magnetic poles are not evenly distributed around the rotor, and they usually have a large number of poles for lower speed operation. The rotor has visible, projecting poles with concentrated windings around each pole. The shape of the rotor is short and broad, making it mechanically stable at lower speeds. Typically used for low-speed operations around 100 to 400 RPM. Common in hydroelectric power plants, as they are well suited for slow-rotating water turbines. Now to discuss the models that represent these machines. Keep in mind there are numerous types of models for a synchronous generator. GENROU and GENSAL are just two very common models. The GENROU model represents the round rotor generator's rotor and stator dynamics in both the direct axis, D-axis, and quadrature axis, Q-axis. Each axis has its own set of reactances and time constants to simulate the electromagnetic and mechanical interactions accurately. The D-axis generally represents the flux produced by the field winding, which influences reactive power and voltage control, while the Q-axis captures the effects on active power output and torque. These two-axis representations allow the GENROU model to simulate complex generator behaviors. The model also includes parameters for transient and subtransient time constants, which capture the rotor's response to changes in magnetic flux due to disturbances. The time constants for the D-axis and Q-axis govern how quickly the rotor flux responds. Now, the GENSAL model operates the same way. It's a series of differential equations meant to represent a salient pole synchronous generator, like GENROU. It also considers transient and subtransient parameters in the DQ reference frame. Both these models are standard to PSSE, PSCAD, and other modeling softwares for engineers. At least that's what that bastard Lincoln wants anyhow. If the Southern cause is lost, the Northern tyrants may force all of us to become engineers.
That cannot be allowed. We need to launch an offensive into Maryland immediately. If we catch Lincoln building any synchronous generators, we will burn them to the ground. Jackson, you need to march towards Harper's Ferry and kill any Union soldier you catch developing software.
Yes, sir. General Lee, it will be done.